Okay, so we want to talk to you about an assignment and a set of tutorials designed to teach algorithmic fairness and predictive modeling early in the computing curriculum, so in Introduction to Data Science courses or in CS1, and we're going to be doing it with the COMPAS Recidivism Risk Assessment Tool dataset, which was extremely prominent in the last several years. So that's a dataset that ProPublica, a journalism outlet, obtained in 2016 and analyzed with respect to bias, with respect to race. So specifically what ProPublica found is that this system designed to predict whether someone would be rearrested or someone would reoffend was about twice as likely to label African Americans who would not end up reoffending as being likely to reoffend than similar Caucasian defendants. So that kind of created conversation in the algorithmic fairness community about the different ways in which you can measure the fairness of a system. So you can have false positive parity. So the disparity in terms of the false positives, that's what ProPublica found. You could have false negative parity. You could have something like accuracy parity. Finally, you could have calibration, which COMPAS actually did satisfy, although it did not satisfy false positive parity. So what was very quickly pointed out is that you cannot satisfy more than one of those at the same time if the base rates, so the percentage of people who actually end up reoffending, are different in different demographics. So what Dressel and Farid found and published in Science Advances in 2018 is that actually COMPAS, while you might think about it as this black box system that's doing something very complicated, is probably actually doing something very simple. So a logistic regression that just uses sex, age, and the number of prior offenses, not race, similarly to COMPAS, can achieve accuracy that's similar to COMPAS. It also exhibits other characteristics that the COMPAS scores exhibit. Specifically, there's no false positive parity, but calibration is satisfied. So in the assignment, what the students are doing is reproducing all of those results from ProPublica and from the Science Advances article. So they compute, for example, the false positive rates. They show that they're different for different demographics. They then build a model which is fair with respect to the false positive rates, so that they're equal across demographics. So that's pretty easy to do. So you just say, well, if my threshold for like the output of the logistic regression is 0.5, then that gives me a false positive rate of 21% for Caucasians. So the threshold here, this one, would also produce the same false positive rate for African Americans as well. What you see here is just sample Python code that students might write if they're doing the assignment in Python. And as you see, that's the kind of thing, for loops, simple if statements, that you want students to be doing in CS1 anyway. Now, if you're teaching it in CS1, not data science, you do need to teach predictive modeling in your CS1 class. That would probably take about 2 hours. We provide tutorials at this website in both Python and Java. We also provide really simple APIs that you can use when teaching logistic regression just as a black box, either in Python or in Java. For Java, we also provide a simple graphics API so that students can produce a figure that's similar to this one. So data science, increasingly important and prominent. You can and should incorporate elements of data science in your CS1 course. Of course, if you're teaching data science, you should teach about algorithmic fairness. But also, if you are teaching CS1, you should teach algorithmic fairness. That's becoming an increasingly prominent topic, something that every computer scientist should know about. Again, go to our website here for all of the materials. Thank you.